Welcome back, everybody, for another deep dive. This time, we're diving into the world of 3D CAD modeling.
Ooh, CAD.
Yeah, the software that engineers use to bring all sorts of designs to life.
Right, everything from like everyday objects to super complex machinery.
Yeah, exactly. And you've probably seen the results of this technology, like firsthand, without even realizing it.
Oh yeah, for sure. It's the foundation for like pretty much everything in the modern world.
Absolutely. But traditional CAD modeling, it can be really time-consuming
Oh yeah.
and complex. It requires, like, a ton of expertise.
You're telling me
Yeah.
it's like you have to draw every single line and curve and extrusion.
Oh.
You need to like really understand the software to have a lot of patience.
So much patience. But what if there was like a faster, more accessible way to create these models?
Well, that's where 3D CAD reverse engineering comes in.
Okay,
It takes an existing object like a 3D scan, and then it uses software to generate like the CAD model from that.
that's super cool. And that's exactly what we're exploring today
Yeah.
with this research paper on a new method called CAD Recode.
CAD Recode. What's so cool about it is that it uses AI
Okay,
to completely change how reverse engineering is done.
gotcha.
And it's not just about speed.
Right.
It's about like opening up the design possibilities to way more people.
So the research paper kind of dives into like the major challenges with this traditional CAD reverse engineering. For example, the output often doesn't work very well with the CAD software that designers actually use.
Yeah, that incompatibility can be a huge problem. It's like trying to fit a square peg in a round hole.
Exactly. And then on top of that, a lot of these existing methods require you to like train entirely new AI models from scratch,
Yeah,
which is crazy expensive and time consuming.
it is.
So the team behind CAD Recode, they came up with like a pretty brilliant solution
Okay, well, let's move on.
using LLMs
Uh-huh.
or large language models.
Yeah.
It's the same type of AI that powers all those like conversational chatbots you might have seen.
Oh, yeah.
It's pretty remarkable how versatile these LLMs are.
They really are. I mean, they can understand and generate human-like text.
Yeah.
But what's even cooler is that they can write code,
Whoa.
including the Python code that's used in a lot of CAD programs.
So it's like having an AI assistant that can actually speak the language of CAD software.
That's a great way to put it.
I'm already intrigued.
Yeah, so CAD Recode, it takes a 3D point cloud.
A point cloud.
Yeah, which is basically a collection of data points that represent the shape of an object.
Okay.
And it uses an LLM to translate that into CAD command.
Gotcha.
And those are written in Python code.
So it's essentially like interpreting that 3D scan
Right.
and turning it into instructions that the CAD software can actually understand.
Exactly.
Yeah.
But the choice of CAD software is really important here.
Oh, okay.
CAD Recode uses CAD Query.
CAD query.
Yeah, it's a Python library for CAD modeling.
Okay, so why CAD query specifically?
Well, for a few reasons.
Okay.
One is that it produces code that's super modular.
Modular.
Yeah, you can use like pre-built elements like
Yeah.
boxes and cylinders,
Oh.
which lets you make way more complex designs than just drawing individual lines and circles.
So it's like having a set of building blocks that you can snap together
Yeah.
rather than like having to sculpt everything from scratch.
Exactly.
This must streamline the whole design process like considerably.
It totally does. Plus the CAD Query code.
Yeah.
It's really easy for humans to understand and edit,
Oh,
even if they aren't CAD experts.
that's huge.
And since it's all based on Python,
Right.
it aligns perfectly with what the LLM can do.
Okay, this is all starting to make sense.
Good.
But how did the researchers actually train CAD Recode?
Ah.
Don't you need a ton of data to teach an AI how to design?
You do. And that's where things get really interesting.
Okay.
See, existing CAD datasets, they're pretty limited
Okay.
in both size and diversity.
Gotcha.
So these researchers, they actually created their own synthetic dataset
Whoa.
of 1 million CAD models.
1 million.
Yeah.
That's mind-blowing. How did they even create that much data?
So they developed this special algorithm
Okay.
to generate a bunch of different and valid CAD models,
Okay.
all represented as CAD Query Python code.
Gotcha.
So instead of using real-world examples,
Right.
they built a virtual training ground for the AI.
That's some serious ingenuity.
It is.
Okay, so they taught CAD Recode to design by showing it 1 million computer-generated examples. So then what happens?
So CAD Recode uses a two-step process.
Okay.
First, there's this point cloud projector.
Point cloud projector.
Yeah, and it transforms the 3D scan into a format that the LLM can understand.
So it's like a translator.
Yeah, like a translator that converts the dots of a 3D scan into a language the AI can read.
And then the LLM steps in to decode all that.
Exactly. It acts as a decoder,
Gotcha.
predicting the sequence of CAD query code that will recreate the 3D model in the CAD software.
So the LLM is basically writing a step-by-step recipe for building the object based on that translated picture.
You got it. It's a really clever combo of a lightweight point cloud projector with the powerful language processing of a pre-trained LLM.
So they found a way to leverage the strengths of both technologies.
Exactly.
But how well does it actually work?
The results are amazing.
Really?
Yeah, they tested it on 3 different data sets.
Okay.
CAD Fusion 360 and CC3D.
Okay.
And those include computer-generated and real-world 3D scans.
Right.
And remember, CAD Recode was only trained on synthetic data.
Right.
So these were all cross-data set evaluations.
That's a key point because it means CAD Recode wasn't just memorizing specific designs.
Right.
It was actually learning how to generalize its knowledge to new objects.
Exactly. And get this.
Yeah.
It consistently beat the existing methods, even the ones that were trained specifically on those test data sets.
So it's not just good, it's setting a new standard.
I'd say so.
What are some of the potential applications of CAD Recode beyond just like generating these 3D models?
Ooh, there's a lot of potential.
Yeah.
One really cool area is CAD question answering.
CAD question answering.
Yeah, or CAD QA.
Okay.
And that's where you can ask questions about the model using natural language.
That sounds super intriguing.
For example, you could ask, what is the diameter of this hole?
Okay.
Or how many faces does this object have?
So you're like interrogating the 3D model using plain English?
Yeah, like you were talking to a human designer.
That's incredible.
And CAD Recode makes that possible because of its Python code output.
Okay.
So the researchers used another LLM called GPT-4o.
GPT-4o.
Yeah, to answer those questions about the models.
Wow. And it worked.
Yeah, and with crazy accuracy.
That's amazing.
Yeah.
It really opens up the possibilities for how we can interact with and understand these complex 3D models.
It really does. What about editing the models?
Oh, yeah. Can you do that with CAD Recode?
You can. They actually developed an editing pipeline
Okay.
that uses GPT-4o to refactor the code
Oh, okay.
and expose certain parameters as these interactive sliders.
So, like, I could just drag a slider to change the diameter of a cylinder.
Exactly.
It
No
is-
more complex programming or tweaking.
Wow. That's a game changer for anyone who's ever had to deal with traditional CAD software.
Totally. It makes design changes super intuitive and easy.
It sounds like this technology is really pushing the boundaries of what's possible with CAD.
It is.
Like, we've gone from painstakingly drafting blueprints by hand to having an AI assistant that can not only, like, reverse engineer the design,
Right.
but also answer questions about it and let us modify it effortlessly.
It's a total paradigm shift.
So what are, like, the big takeaways here?
I think the key thing is that CAD Recode isn't just about automating a process.
Yeah.
It's about democratizing design.
Okay.
It's giving people, without specialized training, the power to create and modify 3D models.
So it's like the difference between needing a professional photographer to develop your film and being able to just snap a photo with your phone and edit it instantly.
Exactly. It puts the power of design in everyone's hands.
That's incredible. And this could have like a transformative impact on fields like personalized 3D printing.
Oh yeah, totally. Or rapid prototyping, or even education.
My mind is already racing with all the possibilities.
It is an exciting time to be thinking about the future of design.
Well, this deep dive is already making me think about it in a whole new light. It's amazing to see how AI is reshaping creative processes.
It really is. And as AI gets even better, we're going to see even more groundbreaking applications.
I'm hooked. I want to learn even more about CAD Recode.
I know, me too.
But we'll have to pause our deep dive here for now.
We will. But we'll pick up the conversation in part 2.
Okay.
Where we'll delve into the technical details of how CAD Recode achieves these impressive results.
Can't wait. Stay tuned, everybody. Welcome back to our deep dive into CAD Recode. It's kind of crazy to think about how this technology is using AI to not just like recognize shapes, but to actually understand the design, like the intent behind them.
It is remarkable. It's almost like CAD Recode is learning to think like a human designer.
Yeah.
Figuring out the best way to build that 3D model.
In the last part, we talked about how it uses LLMs to generate that CAD code. Right.
I'm curious, what kinds of designs has CAD Recode been able to handle?
So they tested it on a whole bunch of stuff, from basic shapes to more complex mechanical parts with curves and holes, and even multiple components.
So it's not just those like perfectly symmetrical computer-generated models.
Nope.
It can work with real-world objects too.
Exactly. Which is key if it's going to be useful in practice.
Absolutely. And it sounds like it performed well across all those different types of models.
It did. It wasn't just good at one specific thing.
Right.
It was able to apply what it learned to brand new designs.
That adaptability is so important.
It is.
And this is just the beginning, right?
Oh, yeah, for sure.
I mean, as these LLMs get even better
Right.
and are trained on even more data,
Yeah,
we can expect even more sophisticated results.
absolutely. It's exciting to think about.
It is. The research paper also talks about the different metrics they use to evaluate CAD Recode. I know they talked about accuracy,
Yeah.
but what other factors were they looking at? So they wanted to make sure that the AI wasn't just creating designs that looked right,
Yeah.
but could actually be used in the real world.
Okay.
So they use a metric called invalidity ratio.
Invalidity ratio.
Yeah, basically it tells you how often the AI creates a model that can't be used.
Oh, so because it has errors.
Exactly. It's unusable.
Did CAD Recode do well there?
Yeah, it did way better than the other methods.
So it was much more reliable
Yes,
at
sir.
producing designs that could actually be used.
Yeah.
That reliability is key.
It is, if designers and engineers are going to actually use this technology.
What about comparing the AI's output to the original design?
Oh, good point. So for that, they use something called intersection over union,
Intersection over union.
or IOU.
IOU. Okay.
It's like, imagine you're comparing the AI's design to the perfect blueprint.
Okay.
This score tells you how much the two overlap.
Oh, okay.
A higher IOU means it's a better match.
So they were really trying to make sure that CAD Recode was creating those accurate and usable designs?
They were. And they actually included some visuals in the paper.
Oh, cool.
Yeah, they have side-by-side comparisons
Okay.
of the original 3D scan, the model made by CAD Recode, and the ground truth model.
Wow.
It's pretty amazing to see how closely CAD Recode was able to recreate the designs,
So even the really complex ones.
even the complex ones. And it's not just about capturing the basic shape.
Right.
It's about getting those little details that give the design its character.
That's really impressive.
It is. It really shows the power of LLMs
Yeah.
when you combine them with good training data.
You mentioned the point cloud projector earlier.
Yeah.
I'd love to dive a little deeper into that.
Okay. What are you curious about?
It sounds like it's this crucial bridge between the 3D scan data and the language that the LLM can understand.
You're exactly right. It basically converts those points and coordinates from the scan
Okay.
into the language of words and symbols that the LLM can process.
Like a translator between two completely different worlds.
I like that.
Yeah.
It's a good way to put it.
But LLMs are already super complex and computationally intensive.
They are.
So why was it so important for this point cloud projector to be lightweight?
Because if the projector was too complex,
Yeah.
it would just slow everything down and make it way less efficient.
But they had to find this balance between giving the LLM enough information,
Right.
but also keeping the computational burden low.
Exactly.
Yeah.
How did they train the point cloud projector, though?
Oh, that's a good question. Was it separate from the LLM?
Actually, no.
Okay.
They trained the whole system together.
Oh, wow.
So the point cloud projector and the LLM were learning at the same time.
It's like a team learning to work together.
Yeah, it is. And they're both working towards that same goal.
Right.
To create that accurate CAD code.
I like that. It's a reminder that sometimes the best solution comes from looking at the big picture.
I agree. Totally agree. It's about that holistic approach.
Did you have any other questions?
Not really.
But
What about you?
I'm always curious about the challenges.
Oh, yeah, the challenges are always interesting.
Because they usually point to future areas of research. And I
Right.
remember the paper mentions some limitations in handling really small features.
Yeah, you're right. So the algorithm basically rounds off certain measurements to the nearest unit.
Okay.
And if a feature is smaller than that unit,
Yeah.
it might just get lost.
So it's like trying to draw a fine line with a thick marker.
Yeah, exactly. You're not going to capture those details.
And the researchers acknowledged that as an area for improvement.
They did?
There was also something about limitations with the types of CAD operations that CAD Recode can handle.
Right. It can't do everything a human designer can yet.
Like what?
So it's really good at that one fundamental aspect of CAD modeling.
Okay.
But there are other operations like creating revolved or swept shapes
Right.
that it can't do yet.
So still early days for the technology?
It is,
Yeah.
but there's a ton of potential
Yeah.
to make it even more versatile.
What do you think the broader impact of CAD Recode is going to be?
Oh, it could totally change the way we design and manufacture products. In what way? Well, for one, it could speed up the process a lot,
Yeah.
allowing designers to experiment with way more ideas
Right, and iterate faster.
so much faster.
Yeah.
Imagine being able to take an existing object,
Yeah.
reverse engineer it, and then modify it to make something totally new,
That would be amazing.
right? You're reusing and adapting designs instead of starting from scratch every time.
It gives designers so much more freedom to think bigger.
Yeah.
Because they're not limited by how long it takes to manually create every detail.
Exactly. And it's not just about speed.
Right.
CAD Recode can also make these tools available to way more people.
Yeah, that democratization aspect.
Exactly. Like imagine a world where anyone with a 3D scanner
Right.
and like a basic understanding of design
Yeah.
could create custom objects or change existing ones.
The possibilities are endless.
They are. It could revolutionize fields like personalized medicine.
Where custom designs are essential.
Exactly.
Right.
We could see people creating custom implants or prosthetics.
Wow.
Or even medical devices.
Yeah. That are made just for them.
Just for them.
That's incredible. It feels like we're on the edge of this huge shift in how we approach design.
We are. It's a really exciting time to be working in this field.
I agree. This conversation has been so insightful.
It has. We've covered a lot.
We have. But we'll have to take a short break for now.
Okay.
We'll be back with the final part of our deep dive into CAD Recode,
Sounds good.
where we'll explore those ethical considerations and future implications of this groundbreaking technology. Welcome back to our deep dive into CAD Recode. This whole conversation about AI and design, it's making me think about like the very nature of creativity.
It is a fascinating question.
You know, for so long, we've thought of creativity as like this uniquely human thing.
Right.
But now we have these AI systems like CAD Recode that are generating new designs. It feels like that line is getting blurry.
It does. Yeah. Are we just like shifting creativity from humans to machines?
I don't know. I think I see it more as like an expansion of what creativity can be. You know, AI is challenging our assumptions about that whole process.
Right.
And maybe even like revealing new ways to understand it.
So instead of seeing AI as this threat to human creativity,
Yeah.
maybe it's more like a tool
Yeah.
to learn more about
Yeah,
it.
right. To enhance our own abilities.
Exactly.
And maybe even inspire us to break free from our usual ways of thinking
Totally.
and explore these like new creative paths.
Yeah. Imagine like a collaboration between humans and machines
Yeah.
where they're both pushing each other to be more creative.
I love that idea.
Yeah. It's not about competition.
Right.
It's about finding ways to work together.
To use each other's strengths.
Exactly.
Yeah.
And I think CAD Recode is like a perfect example of that.
Totally.
You know, it's not replacing designers.
Right.
It's giving them new tools to be creative.
So what are some potential applications of CAD Recode that you're like most excited about for the future?
Ooh, let's see. I think personalized design is super interesting.
Yeah.
Imagine scanning your body or your home and then using AI to create like custom fit clothes or furniture or even medical devices.
So we're moving away from those mass-produced items
Yeah.
towards a world where design is tailored to each person.
Exactly. It could revolutionize accessibility.
Yeah.
People with disabilities could get products designed just for them.
That's a really powerful application.
It is. What about you? What are you excited about?
I'm really excited about how CAD Recode could speed up innovation in like engineering and manufacturing.
Well, yeah.
Like imagine being able to rapidly prototype new designs
Right.
and test different ideas in a virtual world before you even build anything physical.
It would make the whole process so much faster
And more efficient.
and way less wasteful.
We could create these objects with insane details and performance.
Yeah, that would be almost impossible with traditional methods.
It feels like we're on the verge of something huge.
We are. It's a really exciting time.
We've covered a lot of ground in this deep dive into CAD Recode.
We have, from the technical stuff to the creative possibilities.
Yeah.
It's been a journey.
It has. And I hope our listeners are feeling as inspired as we are
I hope so.
by the potential of AI to like completely transform design.
And push the limits of human creativity.
If you're feeling intrigued, we encourage you to check out the research paper for yourself.
Yeah.
And really think about all the questions that it brings up.
The future of design is happening now.
It is. And it's up to all of us to shape it responsibly.
Thanks for joining us for this deep dive.
And we'll see you next time for another one.